situation. All right, let's take a look at the next visual. The next visual shows us an example of what I continue to call a potato diagram. That bothers you, I'm sorry, I like that name. For the inverse of our function. And we write that f with that -1 on top. That is the mathematical symbol for f inverse, the inverse function. And notice the numbers are the same as before, except now instead of going from -3 to 9, the arrow curved line, I guess you call it, is going from 9 to -3. And in fact, the arrow beneath f inverse is going from right to left. And the reason for that is the inverse function takes us from the range to the domain. And now what I'd like to do is to look at a few functions and see how to find their inverse. And I think I'll do these at the board. Probably easier to see that than looking at some visuals. Let's go here to the board. And the first function I have for you is y equals 3x minus 7. Okay? And I want to find the inverse. In other words, this says, give me an x, triple it, subtract 7, and that's the y. I want to give you a y, and I want you to find the x. Now, sometimes this may be written as f of x equals 3x minus 7. Should that make a difference? Probably not. All right, let's see what we do here. Well, the first thing we say we want to do is we want to get x as a function of y. We want to given a y to find the x. So let's do that. We've done that before. Back when we were solving systems of equations, we went ahead, if you remember, and we tried to, by substitution, try to get x as a function of y or y as a function of x. So let's get x as a function of y. Let's add 7 to both sides and then divide by 3. And I'm going to switch this around because if y plus 7 equals 3x, then 3x equals y plus 7. So I'll divide both sides by 3 and flip this around, and I get this. The inverse function is obtained if you give me a y, I add 7 and divide by 3. There's two interesting things to notice here. One, in the original function, I multiplied by 3 first. In the inverse function, I divide by 3 last. In the original function, I subtracted 7 last. In other words, after I multiplied by 3, then I subtracted 7. Here, in the inverse, I add 7 first. So I do the inverse thing. I add, since I subtracted, I divide, since I multiplied, and in the opposite order. If you understand that, then you can look at the answer and say, yes, this is the inverse. If that didn't make a whole lot of sense to you, that's still okay. Process down here like this, and you'll get the answer. By the way, in many books, this is then written this way. F inverse of x, and we replace the y with x. And I know this bothers a lot of people, because you say, wait a second, this is x, no, that's x. No, they're both x, and they're different x's. We like to write our equations in terms of x. X is sometimes called a dummy variable. If you don't like x, that's okay, but this is what's the convention. So certainly this would be a nice answer for the inverse, but your teacher may require you to write it this way. All you do is replace the x with f inverse of x. That's the outcome when I get the inverse. And x is what I'm going to put in, which of course is up here what I called y. In fact, let's take a look at an example. Let's go back to the original function and put in a 2. Ordered pair, x is 2. When I put in a 2, what do I get out? Well, 3 times 2 is 6, minus 7 is -1. Now remember, the inverse function is the opposite. I'm going to put in the answer and get the question. So here I'm going to put in -1. -1 plus 7 is 6, divided by 3 is 2. And you'll notice that indeed this is the opposite order. Okay, so here x is -1 and here y is -1. That's okay. We know this is the inverse and this is the function. Okay, it shouldn't bother you too much. It really is just notation. And understand these are two separate functions. This one happens to be the inverse of that. And the way to check it is simply plug a number in, the original function, see what you get, take what you get, your answer, your output, plug it into the inverse, and you should get what you started with. Okay, let's try another one. Let me erase this here, and let's try an example of one that uses squares. Let's try y, or f of x, equals x squared plus 5. This says take a number, multiply it by itself, and add 5. Oh, by the way, is that a function? We didn't ask ourselves that question before, but the fact is we had y equals 3x minus 7. Is there any number you can't multiply by 3 and subtract 7 from? Of course not. And you always get one answer. Same thing here. If I take a number, any number you like, positive, negative, fraction, decimal, large, small, 0. If I square it, do I only get one answer? Yes. If I add 5, yes, I only get one answer. Okay? In fact, let's take an example. What's a good example? Let's put in x is 3. If x is 3, what's y? Well, 3 squared is 9. 9 plus 5 is 14. And unless you don't know how to square or add 5, you'll always get the right answer. And it'll always, I could do this problem. I can give this problem to anybody who understands the symbology in any country in this world. At any time, I go back 50 years ago, go into the future. I give them this and I say 3 is x. They should always get 14. It is a function. Let's find the inverse. How can I find the inverse? I've got to solve for x. Okay, I've got to solve for x. How am I going to do that? Well, first thing I got to do is get rid of the 5 by subtracting. And then I'm going to solve for x. How do you get rid of a square? You do the opposite. You take the square root. So I'm going to take the square root of both sides. I'm going to get x equals the square root of y minus 5. Now, that's the inverse. We could write it as f inverse of x equals the square root of x minus 5. Notice something. There's a limitation going to be placed on this x. Can x be 0? 0 minus 5 is negative 5. The square root of negative 5, if you know what the answer to that is, make believe you don't, because we'll get to the square root of negatives later on. But most people say the square root of negatives doesn't exist. So how about, well, what's the smallest number that x could be? Because if x is 5, 5 minus 5 is 0, we can take the square root of 0. But certainly x can't be anything less than 5. So x must be greater than or equal to 5. That's a limitation placed on it. There's no limitation placed here, because we can square anything. We can't take the square root of anything, unfortunately. Let's check. Let's put 14 in here. Why 14? Because that was the answer in our original ordered pair. Put 14 in. 14 minus 5 is 9. The square root of 9 is 3. Now, some of you may be saying, wait a second, the square root of 9 could also be negative 3. Well, I want this to be only the positive square root. If you want, we could put absolute value symbol around it, if that makes you feel good. But I just like to say, hey, when I take a square root like this, it's always going to be the positive square root or possibly 0. And indeed, notice, I put in 14, I got 3. When I put in 3, I got 14. This checks. This indeed is the inverse function of this function here. Okay. Also, we have adjectives that we could put in front of the word function. Different types of functions. Because, again, think back to the very first lesson we talked about models. If we're going to build a model of some real-world situation, we just say this is a function. Your grade point average as a freshman in college is a function of your SAT score. Well, what kind of function is it is the next question. For example, this is a quadratic function. Quadratic means it contains a squared, and the highest power it contains is a square. So this is called a quadratic function, which we'll talk about momentarily. Let's go back over here to the easel. This is a function too. This is a function that's called a linear function. Why? Because this is mx plus b, and we know that always gives us a straight line. Thus, from the word line, we get linear. So here's a linear function. We can get other kinds of functions. Let's take a look very quickly at a very interesting function, and that is the function y equals 1 over x. When you put a number in, what do you get out? I put in 2, I get out 1/2. I put in -5, I get out -1/5. I put in 2/3, I get out 3/2. This is the reciprocal function, okay? Gives me the reciprocal. Now, let's put a number in. Let's put in 2, and we get out 1/2. By the way, are there any limitations on the domain of this function? And the answer is yes. You cannot put a 0 in here. So let's put down x can never be 0 because we can't divide by 0. Okay? What's the inverse? Well, let's multiply both sides by x because I want to ultimately isolate the x. Simply divide both sides by y. And again, f inverse of x equals 1 over x. And again, x cannot equal 0. We can't have a 0 in the denominator. Let's check to make sure this is the inverse function. In the original function, we put in 2, we got out 1/2. So let's put in 1/2 to this function. 1 over 1/2, that's 2. And indeed, notice, we put in 1/2, we got out 2. This is the inverse. You also might notice that these two are the same. The inverse function of this reciprocal function is itself. Very interesting fact about this particular function. Well, now we've seen a lot about functions. We've learned about what a function is, about the notion of domain and range and inverse, and how to find the inverse for various functions. In our next lesson, lesson 14, we'll learn about a very specific function, the quadratic function.